Hey there, those 232 folks. Hopefully you're doing well. You're ready to try to do some of the work for the homework, for the blog posts, etc. And you want to do some Jamovi activities. Our goal right now is to do the Jamovi stuff. Let's get rolling and make sure this stuff makes sense. In this activity, we'll go through and we will work on performing the ANOVA tests using our quantitative variable, our numerical variable, age, and use it with respect to whether or not you believe in gun laws or you oppose them. So we'll go through and we'll run our ANOVA procedure. And as always, make sure that as you're running through these things, check the variables just to make sure that we don't have any missing variables. So I go to gun laws, and I'll edit, and I'll go to edit just in case. And look, I see I don't know and NA. It already seems like it's coded as those, as these are missing values, which is great. But if not, you can go there. It didn't have that. You can always just go to missing value, NA, add missing value, don't know. And in this procedure, we can run through and we can, now it should be ready to roll. So the first thing we're going to do to perform the analysis of variance, we'll go ahead and we'll click ANOVA, go to one-way ANOVA. And in doing so, we'll go ahead and we'll check, run through, and type in age. Type in age, it takes a minute to get the search engine running. Here we go. I will make sure that this is going to be, its label is dependent variable. And that's what I mentioned in the hiccup. We actually are treating gun laws dependent in our brains, but because we're treating it as an association as opposed to something that's causal, we can say if one thing is associated to the other, then the reverse is true as well. So we'll treat this as sort of age being dependent on gun law, but really we're looking at it through that opposite perspective, which also means we will go to gun law and go to grouping variable. And if performance one way, the Welch's one. And this is actually something that means if the standard deviations or the variances are not equal, then Welch's is a better way to perform it. It's a fancy term of whether we want basically if we have same variances of homoscedasticity, but if we have different variances, heteroscedasticity, then the actual typical nova that you may have seen if you've done any other stat stuff over the years, it's a little bit violated. So this one doesn't assume equal variances, which is nice. And then the other component, all you do is make sure we click the descriptive table, descriptive plots, and the table will tell us for gun law whether they favor or oppose, and the ages, how many were in each group, the mean age for each group, the standard deviation for each group, and then that standard error of which helps measure how reliable or the sort of wiggle room. If I would have done this survey again and again and again and again, we might get different sample means each time, but how that varies can be measured by this sort of standard error metric. We also get these plots, and the plots, these 95% confidence interval plots, gives us a range of what we think are plausible values for the population. We don't know the population means, but we hope if we got a decent enough and we were survey and we were lucky enough to get things that kind of fell into place, then this confidence interval should be successful at doing its job. And I mean the population means should be somewhere in between there. Now it's close, but I do think there is actually a distinction between the two. You could actually put boxes in between. And because of that, we know that we can claim a distinction. Now, practical differences are a little bit trickier to find, and sometimes they don't even exist. Sometimes maybe it isn't practical existence, but there's just such a large sample size that the statistical differences pop out. And that's something to keep in mind. We'll explain this a little bit more in Module 6, but I don't want you all stressed that much right now. I want people to just detect these differences. So it does look like the age is higher, and there is like a line that kind of goes, that's a gap between these two. Not this gap where it goes left to right, but like up and down. If I were to zoom in, you could see that those are distinct differences. And it's a little bit higher, so it seems like folks are older. Those who are in favor of it, the average is a little bit older. And so these three things basically perform our ANOVA analysis. And if I wanted to, I know this is now sort of the step 4 in the worksheet. If you were to go to exploration, this is optional. So if you wanted to look at those different values and look for practical differences, I could go to exploration, descriptives, and do what I did before, put age. And age is now going to go into the variables position because this descriptives typically fall in line with our categories, our categorical variables. Maybe you have frequency tables, but the variables are usually considered by default to be the numerical ones we want to investigate. And then if I wanted to go to gun law, skim through, find the things, do the things, and split those values. And I don't really care about the statistics. I'm not going to actually use the descriptives here. I'm going to be more focused on the plot. So I do my histogram density plot as well as my box plot and make sure my outliers, my label outliers is unchecked. And what happens, it provides us these two things. You can kind of tell this is a little bit higher. It looks really similar. So if you think age should be, a noticeable gap in age should be like 10 years, then I maybe not say there's a practical difference. But if you think only a few years is substantial enough to claim that there is a bump in age, then 3 years would be good enough. This is where statistics, basically, that storytelling element really does fall into place a lot more because it really is depending on the subject area, the practitioner, and all those other components put together. And here I can look at the density plots and the histograms, and it does look like they are somewhat distinct from each other. I think there's a similar bump and then goes downward. But I see that they're like, if I were to explain data like we did way back in module 2, it seems like there's a lot of the opposition toward gun ownership. There's a peak here, or not opposing gun ownership, I'm sorry, opposing gun laws. So like it seems like younger individuals, and then it drops down, and then it goes to older individuals. Well, here it seems like it's all sort of balanced out. And so that's something to keep in mind. Small video, that's all we got to do. Otherwise, good luck, and you got this.